Hello friends, welcome to Purushotam Academy. So in this video, we will see R&DC C.O.P problem. Earlier we had made part 1 and this is part 2. So coming to the question, two refrigerators capital A and capital B operate in series. The refrigerator capital A absorbs energy at the rate of 1 kilojoule per second from a body at temperature 300 Kelvin and rejects energy as heat to a body at temperature capital T. The refrigerator capital B absorbs the same quantity of energy which is rejected by the refrigerator capital A from the body at temperature capital T and rejects energy as heat to a body at temperature 1000 Kelvin. So if both the refrigerators have the same COP, calculate the temperature T of the body, the COP of the refrigerators and the rate at which energy is rejected as heat to the body at 1000 Kelvin. So ikkada if you observe this problem carefully, we are having two refrigerators capital A and capital B, and parallelly we are having three bodies which are at the temperatures 300 Kelvin, capital T and 1000 Kelvin. Okay, so here he is asking us to find out the temperature capital T of the body, which is the second body, and the COP of the refrigerators, which is capital E and capital B, capital A and B refrigerator COP, and the rate at which energy is rejected as heat to the body at 1000 Kelvin. So at 1000 Kelvin, the body which is at 1000 Kelvin, the energy is rejected as heat to the body. Okay, so we have to find out that rate at which energy is rejected. So we have to find out capital T, we have to find out the COP of capital A and capital B, and also we have to find out the rate at which energy is rejected as heat to the body at 1000 Kelvin. Okay, so let's find out the solution. So coming to the solution, first of all we will write the given data. So given Q1 equal to 1 kilojoule per second and T1 equal to 300 Kelvin, T2 we don't know, it is capital T, and T3 is 1000 Kelvin. Okay, so the arrangement of refrigerators A and B, which will be as shown in the figure. Okay, so if you observe the figure carefully, we are having two refrigerators capital A and capital B. Okay, and we are having three bodies which are at a temperature 300 Kelvin, capital T and 1000 Kelvin. Okay, so from 300 Kelvin the heat is rejected, which is Q1. Okay, and for the refrigerator capital A there is some work done, which is WA, and from capital A the heat rejected is Q2, which is nothing but Q1 plus WA. Similarly, after T also, if you see carefully, Q3 equal to Q2 because there is no work done. Okay, and at refrigerator capital B there is some work done, WB. Okay, so therefore Q4 equal to Q3 plus WB. Okay, so this is the arrangement of the refrigerators and the three bodies, and now we will find out the solutions. So first of all we have to find out the temperature capital T of the body. So we know that the COP for refrigerator A, COP equal to T1 by T2 minus T1, that equal to 300 by T minus 300, and let us assume this as equation 1. And COP for refrigerator B, so COP of B equal to T2 by T3 minus T2, where we don't know the value of T. Okay, and we know the value of T3, so we will substitute the values, that equal to T by 1000 minus T, and let us assume this equation as equation 2. Okay, so since COP of both the refrigerators is same, therefore equating equations 1 and 2, we get 300 by T minus 300 equal to T by 1000 minus T. So further resolving, we get 300 into 1000 minus 300T equal to T square minus 300T. Therefore, capital T equal to root of 300 into 1000, that equal to 547.7 Kelvin. Okay. So therefore, the value of capital T equal to 547.7 Kelvin. Okay. So we will go for the next constant. So we have to find out the COP of the refrigerators capital E and capital B. So as we already known the values of COP which are represented in equations 1 and 2. Okay. So since COP of both the refrigerators is same, therefore substituting the value of capital T in equation 1 or equation 2, we will get the COP. Okay. So COP of A equal to COP of B, that equal to 300 divided by 547.7 minus 300, that equal to 1.21. Therefore COP equal to 1.21. And coming to the next constant, rate at which energy is rejected as heat to the body at 1000 Kelvin. Okay, so we have to find out Q4. So we know that work done by refrigerator A, WA equal to Q1 by COP of A. Okay, as we know the value of Q1 is equal to 1 and COP 1.21, substituting the values, that equal to 1 by 1.21, which is 0.826 kilojoule per second. And heat rejected by refrigerator capital A. So Q2 equal to Q1 plus WA. So we got Q1 1, which is in given data, and WA 0.826. So substituting the values, we get 1.826 kilojoule per second. So now work done by refrigerator capital B. So WB equal to Q3 by COP of B, that equal to 1.826 divided by 1.21. So you may ask how we are substituting the value of Q2 in Q3. As Q2 equal to Q3, we can substitute the value of Q2 in Q3. Okay. So since Q3 equal to Q2, we got 1.826 divided by 1.21, that equal to 1.51 kilojoule per second. Heat rejected to the body at 1000 Kelvin. So Q4 equal to Q3 plus WB. So we got Q3 equal to 1.826 and WB equal to 1.51. So substituting the values, we got the value of Q4 as 3.336 kilojoule per second. So the value of Q4 is 3.336 kilojoule per second. Okay. If you are having any doubts, please comment in the comment section and definitely I will help you.